This video gives you complete directions on an assignment that is normally done in class. However, when you're absent from class or your period didn't have enough time to complete the assignment, this will be very, very helpful for you. So, first thing you need to do is read what you see on the screen right now by stopping the recording. Now you need to get out a piece of paper where you're going to actually do your work. And you're going to call this Whizzy's Periodic Table Lab. And you're going to have actually 3 different things that you'll write down based on the directions that you just read. The best thing for you to do is go back and actually copy those directions, leaving spaces between each of the numbers so that you can actually go straight through and not have to wonder what it is you're supposed to do by going back in the video. So, next thing I'm going to do is take you right to the website. So, first of all, we'll start out at my website. And your directions to get to Whizzy's little periodic table is, first of all, hit Learning Center, hover there, now come down below the line, hit Web Helps, and then go to Chapter 5, as you see me doing. And under Orbitals, which are, let's move this down a little bit so you can see better. The second item under Orbitals is David Whizzy's periodic table, and you want to click on Visit Site, and that's where you're going to get a periodic table that looks like this. I like to start with everything set for hydrogen, and you do that, of course, by clicking right here. So what that gives you is just one electron in the 1s sublevel. The SP and D stand for sublevels SP and D, and they could be on whatever period we're talking about. So we're going to be dealing with periods 1, 2, 3, and 4. And your job is to click on those and look at this area over here where it's kind of arranged somewhat similar to an orbital diagram, orbital filling diagram. And so we then want to also try to coordinate with this side. One little observation I'll kind of help you with is, if you will watch here as we click on hydrogen, note that the nucleus of the atom is right there at the tip of my arrow now. It's just a little tiny dot. And this guy going around it represents this, a 1s electron, which is all we have in the electron configuration of hydrogen. Now, as you go to lithium, watch what happens to the distance of the rotating electron from the nucleus. Or, yeah, the distance from the nucleus. Here we go. Now let's go back to hydrogen. And again, didn't move a whole lot, but actually, as you see over here, this is your corresponding 1s electrons, and these guys have actually moved in their position down because the nucleus is down in this area. When you first play with this chart, you think that this is the 1s electrons, and it is not. And you know, if you had beryllium there, you'd see this type of configuration, and as you go back to lithium, you only have 1, and this is actually on principal energy level 2, as you see across here. So now let's click across a row up here, lithium, beryllium, and watch what's going on. That's what your job is to see what's going on in the 2 chart areas, the one over here and the one over here. As we go down the column and we add more principal energy levels, watch what happens to the proximity of the 1s electrons. You notice that that is quite different from what we see up here and what we would see with helium. Okay, but when we go to lithium and then down to magnesium, now we have another energy level, and we have a single electron in the 1, 2, 3s orbital. The 3s orbital is that distance, relative average distance from the nucleus. And you notice our 1s electrons are moving in closer to the nucleus. And okay, I'm just kind of helping you with some ideas of what you might want to be looking for. And as you're getting all the way down to potassium, you can see that these guys have gotten closer to the nucleus, and these guys over here. Now, actually, you could write down some of this narrative that I'm giving you right now. Okay, now I'm going to go across. The across is here, 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 here. You're watching what's going on as you go across all the way to krypton. And your observations are for both the left side and the right side. Your last thing is to, and I would recommend you do something like sodium to keep it relatively simple, but got enough there so you can kind of see what's going on. And now let's go from shell view. You see when I click on shell view, that's where we are right now. And then we go to nuclear view and watch what happens. Now you are supposed to describe what you think just happened. And that's that will be your observations. I'm looking for 2 observations in what's happening over here as we go from nucleus view to shell view. Obviously nothing will happen over here because you're not changing an atom up here that you're looking at. You're not looking at the atom's electrons. As you go back to shell view, now you're seeing the nucleus get really, really small, and the electrons are getting bigger because that's what you need to figure out. Have fun, turn your assignment in tomorrow, and everything will be well. Thank you for watching.